I'm going to prove that not all Etch-a-Sketch reflections are isometries. So before we begin, we need to understand the definition of a reflection, which is when a point is flipped over an axis and mirrors exactly that line. An isometry means same distance, so the distance is always preserved. So here's what I will be reflecting today. I have the point 0, 5 and 0, 0. So my initial distance I know is 5 because it's 5 units away from each point. So I am supposed to draw a mirror line perpendicular through the point that's being reflected. I then have to draw a new image the same distance to that mirror line as the original point, and it is always on that mirror line. So here I have my two starting points, and I've chosen the mirror line y equals 2x. So y equals 2x. Perpendicular means opposite reciprocal. So I have to take the opposite reciprocal of this equation, and it is now y equals negative 1/2 x. So my new equations for each of the lines going through my points are y equals negative 1/2 x plus 5 and y equals negative 1/2 x. I need to find the intersecting points of the mirror line and perpendicular lines, and to do this I would need to set them equal to each other. So I have negative 1/2 x plus 5 equals 2x. And when solving negative 1/2 x plus 5 and 2x, I would multiply each side by 2, which is what I did here. And then I would get negative x plus 10 equals 4x. If I add the x's, I'm left with 10 equals 5x. Divide each side by 5, and I'm left with x equals 2. So with that 2, I have to plug it in for one of the equations. So y equals 2x. Plug it in, I get y equals 2 times 2, which is y equals 4. So my new equation, or my new point is 2, 4. This is on the mirror line. So here are my original points, 0, 5 and 0, 0. And my new point that I just found is 2, 4. Sorry, my mirror line doesn't go exactly through that, but you get the idea. Okay, so my distance between 0, 5 and 2, 4 is 3. I know this by going down 1 and over 2. 1 plus 2 is 3. I can also figure this out by doing the equation by subtracting the x coordinates and adding them to the subtraction of the y coordinates. 0 minus 2, absolute value of 0 minus 2 plus absolute value of 5 minus 4. I'm left with the absolute value of 2 plus the absolute value of 1, which is really 2 plus 1, and that equals 3. So I've confirmed that my distance between 0, 5 and 2, 4 is 3. So when reflecting, I would just take that distance and do the same thing on the other side. So by going down 1 and over 2, my new point is now 4, 3. This is my new image, 4, 3, which is reflected across the line. X is equal to 2 plus 2, which is equal to 4, and y is equal to 4 minus 1, which is equal to 3. This is the way I can confirm it. 0, 0, this point stays the same because it is on the mirror line. The mirror line runs right through it, so it's therefore reflecting upon itself, so the point would just remain at 0, 0. So if I remember back to the beginning, my initial distance was 5. Because my original points were 0, 5 and 0, 0. So the distance between them is 5. Now I have to find the distance between 0, 5 and 4, 3. Or the distance with the point 4, 3 to confirm that it's the same. So if I'm doing it as Etch-a-Sketch, I'm going over 4, 1, 2, 3, 4, and up 3. 1, 2, 3. So my new distance is now 7. Another way that I can confirm this is by doing the absolute value and subtracting. So 0 minus 4 plus the absolute value of 0 minus 3. I'm left with the absolute value of 4 plus the absolute value of 3. 4 plus 3 is equal to 7. My new distance is now 7, which conflicts with my initial distance because 5 is not equal to 7. So therefore, I have just proved that this reflection is not an isometry because the distance wasn't preserved. So not all reflections are isometries.